Machine learning and AI projects. They run on data. Accurate reports can't be generated, and compliance is time-consuming and difficult. Machine learning and AI project efforts are generally broken down into 50% to make the data harmonized and fair. And fair is findable, accessible, interoperable, and reusable. We'll go into depth about fair data later, but 25% of the effort will be in the software used to create harmonized fair data, and the other 25% is going to be on internal efforts of the company doing the project. In my experience, in the last 10 years, about 80% of companies are lacking a strategy, and even fewer have a plan to execute the solution. Today, we're going to talk about executing on the solution. Usually when people talk about data analytics and the way to get to an AI-driven company, they talk about the 3 stages of analytics maturity. There's descriptive. You can do analytics of all your business data. Is all of your data accessible? Can subject matter experts create reports and dashboards? And do you do trend analysis using KPIs? This is usually called data analytics with a rear view mirror because it focuses on the backward and the past. Predictive. Have you turned your trend analysis into statistical models so you can do business forecasts based on your historical data? Here's an example. Is your critical infrastructure in your company serviced using predictive maintenance? Are you optimizing your production pipelines by matching real-time data from IoT devices to your trained models? And then finally, prescriptive. Do you make use of generative artificial intelligence and large language models at scale for automated action plans using robust mechanisms to discern and filter out erroneous information? Because we all know ChatGPT can hallucinate at times. And we'll get more into that on the next slide. So your data analytics maturity level from the slide before should match your digital lab maturity, matching real-world counterpart descriptive, predictive, and prescriptive. This is where ingesting and cleansing all data is the foundation and the start of the journey. In order to automate, you must first harmonize data. In a lab, you're going to form a data-centric view and descriptive analytics to a business-centric view with prescriptive analytics. Everybody's always interested in their results and deciding what to do next, which results in a request to do a new test or experiment. The next maturity level is reached when you're automating this test request. In order for this to work, you'll need models and workflows that know what you have done in the past and can apply that to the next action, which still needs a scientist to also be a technical specialist for all instruments and robots involved. This only changes when your lab is becoming smart and the scientist tells the instruments what to do. But the how, the method, is coming from a repository of methods and is communicated to the instrument. A simple example from your own home are the smart temperature settings in your rooms. In a data-centric world, you have a thermostat on your heater, from which you turn up and down to achieve the perfect room temperature as a result.